Fifth episode, we're gonna look at material science and manufacturing this one, but I'm starting this one off just looking at the company because I'm gonna be honest with you. I can say I'm not the most well-versed in these fields, material science manufacturing, but some of the stuff that we're gonna discuss, I don't know if they're working on yet. I don't know how to describe, but I'm like, I don't know if I should show y'all. But look, this is the nature of the beast. This is the series. Let's go. So what I'm gonna do is show you some information that came up with the company first. Here, this is the prompt I use. Please outline needed infrastructure, blah, 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 blah. And then this is what he gave. Feel free to pause and read at your leisure. But this is some of the information because, man, some of the stuff we're about to talk about, I'm like, maybe, anyway, so I don't know if any of you guys saw this week, but this footage came out from Jeremy Corbell and George Knapp on their show Weaponized of 29 Palms in Camp Wilson, which is a United States facility. It was some U.S. Marines who saw this hovering in the sky for about 25 minutes. There's some footage where you could just see like almost like if you ever saw the Phoenix lights, you just see like lights flickering, but they said it's more of the an effect of the cameras that they were using, their phones and stuff they were taking footage with, because the lights were the lights were constant. But this was a low light photo, and of course you know how we do things here, shine. We went and revved it up a little bit. It's not much difference. I'll go back and forth a little bit so you can see that's it. It looks a little blurry, and this is a little bit sharper, right? But it does look like something different from the night sky in that, but also difficult for the pixels to pick out, if that makes sense. And they're asymmetrical, but that could just be a function of our technology trying to function that. But whatever it is, looks crazy. So these are the prompts that we developed in, I believe, the first episode from ChatGPT, and then we brought them over and decided what fit with what. I want to put manufacturing at that, but feel free to pause and look at what we look at. And now you know kind of what I do. I put it through the work table saying, hey, rank all of them and tell me what's what. And with that, we found that the number one was this: describe a method for creating lightweight, high strength structural material. Talked about it, composites from carbon fibers and epoxy resins that are being used now, evaluate nanotechnology. So some of this stuff, like I said, a lot of the things that you thought, or I thought would be near the bottom, were like near the top, if that makes sense. Like, oh no, we can do this. It's easy, it's feasible. And some of the things we could talk, like I said, I'm not the most versed in material science, so maybe these are things that have been out there already. But oh my gosh. Wait, so we'll get to it in a second. So we went through it. I went with, it's not even, I can't even tell you which ones. I know one of them we did is 4D. We're going to do 4D. I did not do a lot of the meta materials and nanotech. I was like, it was so many that I was like, I'd rather just do that as one, but some of the other ones. So I believe the least feasible was our number one: design a novel transmedium vehicle material with adaptive properties. So let's get into it. Design a novel transmedium vehicle material with adaptive properties that can seamlessly transition between air, water, and land environments while providing, I should have took out the land, while providing details on this chemical composition, mechanical properties, and manufacturing processes. So it said, look, it's basically a component of three, a smart composite of three things, considering layers of graphene, a self-healing polymer matrix, and embedded nanobots. So the graphene layer, and it talks about graphene is a single layer of carbon atoms arranged in a two-dimensional honeycomb lattice. It is one of the thinnest, lightest, and strongest and most conductive materials known to man. This makes it an excellent choice for the outer layer of our transmedium vehicle, our TMV. The graphene layer would provide exceptional strength and lightness to the vehicle, enable it to withstand the pressures of deep sea diving and high altitude flight, with high thermal conductivity, help dissipate heat generated by air frictions at high speed or under the sun. Self-healing polymer matrix. Underneath the graphene layer, the main body of the material will be composed of a self-healing polymer matrix. Self-healing polymers have the ability to repair themselves when damaged, which is a highly desirable property. Of course, blah, blah, blah. They say they have buoyancy in water, flexibility, absorbing shocks and vibrations, because it would have a microcellular structure similar to that found in nature, materials like cork or wood. And then with embedded nanobots. To enable the material to adapt to its environment, we propose embedding nanobots within a self-healing polymer matrix. These nanobots will be programmed to respond to changes in the external environment, modifying the physical properties of the material as needed. Dope. Manufacturing for this will be complex given the advanced nature. The graphene production will be produced via chemical vapor deposition, CVD, where gaseous reactants form a graphene layer on the substrate. Polymer matrix self-healing will be synthesized through a process like reversible addition, fragmentation, chain transference, polymerization, RAF polymerization, which allows for precise control over polymer structure. The nanobots would either likely be created using advanced nanotechnology fabrication techniques such as top-down lithography or bottom-up self-assembly methods. Composite integration, final step will involve integrating the graphene layer, self-healing polymer, and nanobots in a single composite. Can be done through a lamination process where the graphene is bonded to the polymer matrix. Nanobots are evenly distributed throughout. It's dope. Super dope. But it says highly speculative. Creation of such material require advancements in some things, but it just makes it sound like such a feasible application of things. I'm like, can I create this? Describe a method for creating a lightweight, high-strength structural material that can withstand the extreme conditions of transmedium vehicles, such as rapid temperature fluctuations and high pressures. So and this is what I was like, maybe this already exists, or am I nuts? I mean, please tell me. One promising area of research is advanced composite materials, carbon-reinforced polymers with a nano ceramic matrix. Preparation of the fibers. Just discussed that. Adding this nano ceramic matrix with alumina, silica. Okay, I'm imagine this exists. I was saying that I had to go, but imagine, because it has to already, right? People already do using this. Combination. Did it say where? Blah 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 blah. Wait. Discussion method of creating a lightweight, high strength. So I'm, like I said, man, I'm losing my mind. Anyway, combinations, thermal stability, lightweight, potential applications, multiple industries, aerospace, automotive, construction, energy, construction of infrastructure for renewable energy sources, not resources, like wind turbines and solar panels. I don't know anymore. Propose a novel method for using additive manufacturing to create adaptive, self-healing materials that can adjust to environmental changes during transmedium travel. Given the advanced requirements, we need a method that can adapt to various environmental conditions while maintaining structural integrity. One possible approach is to use a combination of additive manufacturing, smart materials, embedded sensing, and actuation systems. So this is what I was like, does this I don't know if any of this exists. I have to additive manufacturing. So they talked about this. I'm sure this is a thing. Direct metal laser sintering, or fused deposition modeling to fabricate components with integrated multi-material constructs. This process allows us to combine materials with various varying properties in a single print. Combine rigid material for structural strength with a soft shape memory polymer for adaptability and self-healing. Embedding of microcapsules during the additive manufacturing process. We can also embed microcapsules into the material, which, if they need to, could break and then form a polymer. Yes, that heals in that agent. But they also, I was like, what is this? Incorporation of shape memory alloys. SMAs are a class of materials that can change their shape in response to changing temperature. By integrating these into our process, we can create structures that change their shape according to the external environment. So this is talking about using this to adapt the vehicle in flight. And then also in the midst of the printing, also incorporating sensors and actuators to truly create an adaptive system that can sense the environment and respond accordingly. And also having in there machine learning algorithms that can learn over time and make better decisions based on the information as it travels through the different mediums. It said novel method. I don't know. I'm losing my mind. Okay, let's get to the 4D stuff because I had no clue what any of this was before, but I did look up some of this, and this is something that is being worked on anyway. Investigate the potential of utilizing 4D printed materials for the construction of transmedium vehicles, focus on their adaptability, self-assembly, and environmental responsiveness. So at first it just said a little bit, and then I told it, go back and work harder. So I think I told it to go back and work harder at this part because I called them TMVs. I said, hey, explain more about what we use to make a TMV. So let's go through this. Just said that it's a relatively new technology, the production of 3D multi-material parts that we kind of discussed a little bit before that can self-transform over time in response to internal stimuli. So kind of like what we were just discussing. Pre-programmed and have built-in sensing and actuating abilities. So basically what we already figured out we were going to need. This technology, the applications, they've been working with BMW, MIT, utilizing a process known as liquid printed pneumatics. I swear years ago I told my sister, who is an electrical engineer for Ford, that why can't we just spray the electronics onto things? And this has to be 2 or 3 decades ago, back when, so anyway, 4D printing, it's basically what the previous one we discussed. So I told it, hey, come here and talk about it. The construction of such vehicles poses unique challenges, speculating on potential using 4D printed materials. So adaptability, have the unique ability to change shape in response to external stimuli such as heat, light, moisture, and even air pressure. This is, make it more smooth when it's through air, or more streamlined, through water. Some rugged and grippy for land. That's why I take that land garbage off. Self-transform. It's talking about like self-assemble and disassemble like wings and propellers and such. I mean, look, so this one is not as long as last week's because I think I snapped, but we'll figure out. I'm gonna do some further work. Next, we'll probably have a combination of the communications and some of the other ones, so we can, get back around to looking at the company and what things actually could be feasible. Because I'm having some ideas of some type of a drone that may not quite exist yet, but may be feasible with our current technology, let alone if mess around and make something groundbreaking. But with that, you know how the game goes. I love you. You love you. God loves us. And that's all that matters.